Hey guys, it's Gigi, and welcome back to another one of my amazing educational videos. So today we will be talking about the evolution of the universe. Yeah, I know you are all waiting to hear that sound effect again. Okay, so I'm sure pretty much all of you have heard of the Big Bang Theory. Okay, no, not that Big Bang Theory, the other one. Yeah, that one. The one that occurred about 13.8 billion years ago? Well, like most things, the Big Bang didn't just happen. There was many steps to it and a lot of evolution. So today, I will be going over the different epochs of the Big Bang. We will start off by talking about the first of many epochs, the Planck epoch. It all started as a singular point that was infinitely hot and dense, called a singularity. It is believed that at this point, the four fundamental elements, electromagnetism, weak nuclear force, strong nuclear force, and gravity, were all of equal strength. Rapidly, that point began to expand, launching the creation of our universe. The next epoch is called the Grand Unification Epoch. As expansion began slowing down and temperatures began to cool, subatomic particles, such as quarks, neutrinos, electrons, and photons, started to form. For those who don't know, quarks are very, very, very tiny particles that make up all of the matter we know today. As we all know, atoms are made of protons and neutrons. But what are those protons and neutrons made of? They're made of quarks. The next time period is called the Hadron Epoch, because the universe has cooled enough to allow for quarks to combine, forming hadrons, such as protons and neutrons. When the electrons collided with the protons, they would fuse to form neutrons and give off neutrinos. Now, let's watch this process happen. However, some of those neutrons and neutrinos recombined and actually formed proton-electron pairs. Keep in mind that at this point, we have only reached about 1 second since the Big Bang occurred. The next epoch I will go over today is the Lepton epoch. By this point, almost all of the hadrons have destroyed each other, and the majority of the mass is made of leptons and antileptons. The most common type of lepton is an electron, and the most common type of antilepton is a positron. In the nuclear epoch, the formation of nuclei begins. Nucleosynthesis is the process of light element formation. This formation of nuclei occurs through the process of nuclear fusion. Roughly 17 minutes after the beginning of this epoch, the universe has cooled to a point where nuclear fusion halts. Now, this doesn't mean the universe was cold. It was still roughly 5 times 10 to the 9th Kelvin. The photon epoch, also known as radiation domination, is the first epoch to span over a relatively long period of time. For reference, this occurred from about 3 minutes after the Big Bang to 240,000 years after the Big Bang. At this point, the universe was filled with plasma. The photons continued to interact with protons and electrons. Within roughly the first, I'd say 2/3 of this epoch, the majority of the energy is in the form of radiation, hence the name radiation domination. And now we have reached the galactic epoch. Atomic clouds of hydrogen and helium form. The formation of these clouds allows for galaxy clusters to begin formation as gravity starts to act on these clouds of dust and gas. Quasars, massive objects formed in space that emit a lot of energy and contain a black hole and an accretion disk, begin to form. And well, this brings us to our last epoch, the stellar epoch. This is the epoch that we are currently still in today. As the dust and gas within these galaxy clusters was pulled closer and closer together, stars and planets and dust and rock and ice and everything else begins to form. Additionally, galaxies become more defined. So, we've covered the Planck epoch, the Grand Unification epoch, the Hadron epoch, the Lepton epoch, the Nuclear epoch, the Photon epoch, the Galactic epoch, and the Stellar epoch. And well, that pretty much concludes the evolution of the universe from beginning to end. Well, in simple terms, and only up to the point that we've reached today. Of course, it isn't possible to cover absolutely everything that has happened up to this point in the universe in only 7 minutes, but here we are today. I hope you enjoyed and learned a little bit about how we got to where we are today. Bye guys, and thanks for tuning in to another one of my videos. See you next time!